Hello and namaskar. Welcome to another session of BW for HANA Tidbits, where I share some of my knowledge and experience. My name is Debanshu Mukherjee, and today we are going to discuss VARCHAR versus NVARCHAR in SAP HANA. On many occasions, we face the issue of data being truncated while loading the data or querying the data from the columns with VARCHAR data types. And when we switch that to NVARCHAR, we see that the issue is gone. And this particularly happens when we deal with virtual tables, which are a replica of the source tables. And changing the data type of virtual tables might not be possible, at least in HANA 1.0, it's not possible while the creation of the virtual tables. Therefore, to fix the issues related to columns with VARCHAR and NVARCHAR, it's imperative that we understand the difference between VARCHAR and NVARCHAR behavior in SAP HANA. And this video is an attempt to unravel this mystery. So let's get started. So before we delve a little deeper into the difference, let's first analyze the issue at hand. So as you can see in the screenshot, we have a scenario where we have two schemas. The first schema is the HDB-VT schema, which houses the virtual tables, and the second schema is the staging schema, which houses our regular column store tables. And what we did is that we replicated the data from the virtual table into the staging table via a regular insert statement with no conversions or no transformations. And then when, as a part of reconciliation, when we looked at the data from the virtual table and the staging table, we saw that the data is getting truncated. The value of the column, as you can see in the screenshot, from the virtual table HDB-VT, we can see the value ends in SCRP, but the value in the staging table ends in SCR. That means the last alphabet is getting truncated. And also, just for the information, we also have the column from the virtual table as VARCHAR 30, and in the staging table we created the column with NVARCHAR 30. So this was the difference. Now before we troubleshoot it further, we first ascertained or confirmed the value in the source meaning the source of the virtual table, and from the enterprise data hub team we actually learned that the value should end in SCRP, that is the correct value. So that means in our staging table the value was getting truncated. Now, without the union all, when we just queried the virtual table, we were again taken by surprise. Without the union all clause, if we just queried the virtual table for that particular cost center, we saw that the value is truncated in the virtual table as well, SCR. Now, the union all gave the correct value in the virtual table, but without the union all, even the virtual table values were truncated. Why? So all these were open questions, and now let's see what is the actual root cause. Before I can answer that why this is happening, it is very important that we understand first that what is the difference between the VARCHAR and the NVARCHAR data types. So let's look at that first. Okay, so now let's first look at the scenario 1, which is for the Chinese characters and French characters. So of the first scenario, we have taken a Chinese character. So I have created a test table, a column table, which is test underscore data underscore nvar, and it just has one column which is nvarchar 10. And what I am doing is I'm actually inserting 10 Chinese characters in the table. So as you can see, the length of those 10 Chinese characters, or the length of the column, is 30 bytes. That means that every Chinese character takes 3 bytes. And the same table, if I drop and recreate with VARCHAR 10 and then try to insert the 10 Chinese characters, it is basically failing with the error that inserted value too large for column. Okay, why is it the case? Let's look at that. So to incorporate the 10 Chinese characters in a VARCHAR column, what we will need to do is to create a column with length 30, since each Chinese characters takes 3 bytes. So now when I create a column table with one column called name and the data type is varchar 30, and then try to insert the 10 Chinese characters, I can see that the length is 30 now and it is accepted in the varchar 30 column. It no more fails with the error. Same thing if we do for French. So French or Spanish characters, they each take 2 bytes. Chinese characters take 3 bytes and French or Spanish takes 2 bytes each. So now if I drop the table and recreate the table, same column name and the nvarchar 10 is the data type, and I try to insert the Chinese characters, 10 Chinese characters, you can see that the length is 20. And if I do the same thing for varchar 10, again it will fail, saying that the value is too long, and then I have to do what I have to do. I have to change the length of the varchar to 20, and then it can accommodate the 10 French characters. So what is the inference we can deduce from this, or what is the conclusion we can have? The conclusion is that varchar 10 represents 10 bytes, or in other words 10 single byte characters, not 10 characters. So if it says varchar 10, you can accommodate 10 bytes. Now those 10 bytes can be taken by 3 characters or 4 characters or 10 characters, does not matter. As long as you are adhering to the clause of 10 bytes, not 10 characters, you can accommodate that in varchar 10. But in nvarchar 10, it represents not bytes but 10 characters, because every character an nvarchar can accommodate can be multi-byte character, can be 2 bytes, can be 3 bytes, can be 4 bytes, can be 5 bytes. So it does not matter. So nvarchar 10 represents 10 characters of any length of bytes, but varchar 10 represents 10 bytes strictly, not 10 multi-byte characters. Yes, where it can accommodate the 10 characters where each character takes only 1 byte. So this difference is very critical to understand, and only if you understand this can you understand the behavior of varchar versus nvarchar. After this, let's look at the scenario 2 with English characters. Alright, so now let's look at scenario number 2, which is English characters. So French or Spanish characters, we know that it would take 2 bytes each instead of 3 bytes for Chinese characters. But let's see how many bytes English characters take. So I have created the same column and the same table, and this time the first type is nvarchar 10. So as you can see, I'm trying to insert 10 English characters into the table of the column type nvarchar 10. You can see the bytes taken are 10 only. So that means each English character takes only 1 byte. Same thing when I did for the varchar 10. So the same table, I changed the data type to varchar 10, and now when I insert, the result is the same, bytes equals to 10. So that means the inference or the conclusion is, in case of English characters, they are single byte characters. So in case of English, whether you use nvarchar or varchar, it does not matter. It can accommodate the same number of characters because each character is 1 single byte. So this is the major difference between varchar and nvarchar. And now with this knowledge and understanding, let's now go back to our original issue and see how we can resolve that. Okay, so now with the understanding of how varchar and nvarchar behaves, let's look at our original issue. So the issue was that we had 2 schemas, HDBVT, which houses the virtual tables, staging schema, which houses the actual persistent column store tables. And the data which was there in the virtual table, we replicated that data into the staging table. And when we did the union all and we compared for reconciliation purposes, we saw that the data in the virtual table is correct, SCRP, but in the staging tables it was truncated. And on the other hand, we also saw that when we just query the virtual table alone without the union all, the data is also truncated. So let's look at now the reason. So the data, if we just look at from the virtual table, was truncated because of the fact that varchar 30 is equal to 30 bytes, not 30 characters as we saw in our previous example. And therefore the value which is ending in SCR already occupies 30 bytes. Why? Because all the English characters, there are 28 English characters, so that becomes 28 into 1 byte equals 28 bytes. But there is one French character, OPE. The E character is the French character, and that takes 2 bytes as we have seen in the previous example. So 2 and 1 equals 2 bytes. So total 28 plus 2 is 30 bytes. So already the value which is ending in SCR occupies 30 bytes, and that's why the varchar 30 only shows data till SCR, not SCRP. But now the question arises that how come when we do union all, we were getting the value correct in the virtual table? Why? Well, this happens because when we do a union all, the union operator expects the data types from both the tables to be the same. And in our case, the data type of the virtual table was or is varchar 30, but the data type of the same column in staging table is nvarchar 30. So now when the union receives these two different data types, it gives preference to nvarchar, and thus it converts the varchar 30 to nvarchar 40 or 30, whatever is the case with the staging table. And then when the nvarchar 30 is also associated or is also stamped to the virtual table, then that means that now the virtual table can also accommodate 30 multi-byte characters, and that's why the value which ends in SCRP is treated as 30 characters, not 30 bytes, meaning the French character E is treated as a single character irrespective of its byte length. That's the beauty of nvarchar, and that is why the union all shows the complete value ending in SCRP for the virtual table also, because union converted the value of data type of varchar 30 to nvarchar 30 to make it consistent with the staging table data type. And to prove this, what we did was we altered the data type of that particular column in the staging table from nvarchar to varchar, because what union was giving, what union was doing is it was giving the preference to the staging table data type. So we changed the data type of the staging table to make it same as the data type of the virtual table, which is varchar 30, and now we tested it. So as you can see in the screenshot, I have changed the data type to be varchar 30, and after that when we do the union, we can see that now both the virtual table and the staging table are showing truncated values. So the P at the end is truncated. So why inserting data into staging table from virtual table truncates the value? This is because when we write the simple insert into select from clause, we are simply taking the data type of the source, which in this case the virtual table data type is varchar 30, and we put it into the staging table. So varchar 30 already truncates, and you are actually doing nothing but inserting the truncated value into your staging table. And when you do a union all, union basically overrides the varchar 30 from the virtual table to nvarchar 30. Why? To make it consistent with the staging table, and that's why you are able to see the complete value in the union all. But if you just query the virtual table, you are actually querying varchar 30. That means the end value will be truncated. So then what is the final solution? Well, to resolve this, what we need to do is to exactly replicate the logic which was being done by union all in the background. So what union all was doing, it was converting the varchar 30 to nvarchar 30. So that's exactly what we will do, but we will do this while inserting the data into staging table. So I changed the data type back to the original nvarchar 40 in the staging table, and then while I inserted the data, you can see that I am doing a conversion which is to underscore NVARCHAR and then the column type. That means while inserting data from the virtual table into the staging table, I am converting the data type from VARCHAR to NVARCHAR. And then when you do the union, you can see that the data is now properly associated or properly displayed, and it is no more being truncated. And this happened because we converted the data type while inserting the data to NVARCHAR. So this is how you can resolve the issues between VARCHAR and NVARCHAR and have the data correctly replicated into SAP HANA. Thank you so much for listening in. I really hope this video helped you understand the topic and clarify the concepts. Please subscribe to my video for regular updates, and don't forget to give me a thumbs up if you like this video. Thank you, and I'll see you in the next one.